Hello students, I am Professor R. S. Deshpande. I was Director of the Institute for Social and Economic Change, Bangalore. Today I will be interacting with you on Module 15 on statistics, basically talking to you about the central tendencies and variations, etc. Let me begin with the objective of learning the central tendencies. We get a lot of data, and when we get a lot of data, it's necessary to describe the data and the facts collected. Sometimes we collect the data on income, we collect the data on employment, age, etc. We collect the data from the viewers about their satisfaction levels, and these data needs to be analyzed properly. Therefore, it is essential to look at the central movement of this data, and this central movement is the addition, incremental addition to your knowledge. You can give one particular thing, that the users using these educational programs largely belong to the age group of 20 to 27. Now, this particular observation comes after analyzing the central tendency of ages. The data are always meaningless, but the meaning has to be inserted into it by finding out these kind of parameters. These are called parameters. Data are usually available in kind of arrays or matrices. Sometime what you can see in the table, this income data, we have different people earning different incomes. Similarly, the data on the viewers also can be there, that viewers observing the program at differential points of time. Now, what are we learning? Now, these data have to be used meaningfully when we collect them. We need to collect the data in such a way that we are leading to the hypothesis that we have in mind. We need to have especially two properties in our mind, say one, that describes the tendency of the data. Average age of the users watching educational program is 45 plus. Now, my program is not going well. If the average age of the user is between 20 to 27, my program is going to right kind of sample. Second, we summarize the fluctuations, that we want to know what has been the variations in the age of the users or time spent by the users on observing the program. Therefore, the measures of the central tendency essentially describe the central point around which the data are spread. Say, the time spent by a student in observing or learning from the programs. There are three important central tendencies used by most of the statisticians. There are other things which I will not be dealing with, but let me deal with mean, mode and median. Measures of central tendency are typical sources and representative values of that group. These are basic measures of central tendencies, and the symbol for mean is X. On the top of it is a bar, and that is called X bar. Median is M and subscript D. It's called M subscript D. Mode is M subscript O, and it's read as M subscript O. These are three major central tendencies we are going to learn. But above that, the mean is also called arithmetic mean. And since it is called arithmetic mean, there are other things called geometric mean and harmonic mean, which have a little different properties. Let me talk to you about calculating arithmetic mean. Arithmetic mean is the most commonly used measure of central tendency, and therefore it's easier to compute too. It's represented, as I told you, by X bar. And when we have an array of data, say age of the students who are engaged with the program on the TV, we have array of the students' ages. 22 years, 23 years, 27 years, 25 years, 26 years, etc. Now I want to get the average of this. What I need to do is sigma x, which is the summation of these ages divided by the number of students, that's called n. Therefore, mean is represented by x bar, summation or lying m is summation operation, x is the age of the student observing that program, and n is the number of cases that we have taken. This table will give you what is the meaning of group frequency. Now we have the group frequency between the age group of the persons working on certain programs. From 10 to 14 years, I am coming from bottom up, 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34 and 35 to 39. This is the age group of the students, and I found the midpoints of each of these class intervals, and the midpoints are given in the second column. Now the frequency, how many people are there in each of this group, are given in the third column, and that is the frequency. Now frequency multiplied by the midpoint is given in the last column. Now once we have the frequency multiplied by the midpoint, we sum that up, and the total sum is about 584. Now this 584 divided by how many people are there, we total the frequencies, and the frequencies are given in third column. You have the total 22. 584 divided by 22, we get 26.55 as the mean, and that's the arithmetic mean of the group data. Precautions, what precautions we need to take in the mean? Mean assumes normal variation. It doesn't have huge fluctuations. Mean takes into account all the scores. It is applicable only at the level of higher measurement, that is, measurement has to be absolutely perfect. We cannot have doubts on measurement. It is on the interval and ratio variables only. It cannot work on the other kind of variables which are dichotomous. In case of having abnormal values, there is a method called trimmed mean. We take out the abnormal values and calculate the mean of the values which are in the normal. Has certain properties too. The sum of the deviation from the mean is always equal to 0, because mean happens to be a central tendency. The sum of the squares of the deviation from each of the scores of the mean is always less than the sum of the squares of the deviation, and mean does not represent the series in case of presence of some extreme values. Suppose suddenly one retired person wants to be a student and enters into the group. His age is 65. We have an age 65 in the group in which all the ages are between 20 to 29. It's an extreme value. Let me get it to the second measure, median. This is an easier measure. Median is the central point of the entire series. And say we have a series of 5, 8, 13, 14, 18, 22 and 24. Now what is the central point? I leave 3 this side and 3 this side, and I get 14 as the median of the series. It's such a simple thing. Median is the most number of the series, the middlemost number of the series, and that is 14. Another case, there is a tricky situation where the series has 5, 8, 13, 14, 18, 22, 24 and 27, which means 3, 3, 6 and 2, 8. Now 4 this side and 4 this side, there is nothing in between. Now at this time, what I do is I take central two numbers, add them 14 and 18, take the average, take the divided by 2, that is 14 plus 18 divided by 2, and I get to 16, and that is the median of the series. Median is an easier method to calculate, that is the median, which is L plus, that is lowest value, plus n is the total number of observations in that series, divided by 2 minus f. F is the cumulative frequency below that class interval, and divided by Fm is the frequency in the class interval n by 2 multiplied by h, that is the size of the class. Now, calculating median on the distributed data is through this formula, where the data are in the class intervals and you know where the median is lying, because you know you can distribute between, you can exactly find out the central class. Now, this is the data which gives you the total thing. Now, again n is 22 and you have cumulative frequency. Cumulative frequency, which means that 10 to 14 has 1, 15 to 19 has 3, 3 plus 1 is 4 is the cumulative frequency, and 4 plus 3 plus 1, 8 is the cumulative frequency, and thus the cumulative frequency is 1 plus 3 plus 4, 8, 1 plus 3 plus 4 plus 6, 14, and so on. Now, once we have the cumulative frequency calculated, first method is n by 2, the distribution is 22, therefore n by 2 will be 11, and therefore the 11 number has to be looked into that distribution. As you would note, 8 cases have scores below the class interval 20 to 24, because that's exactly 10 to 14 will be the class interval in which your 11th case falls. Thus, the 11th case must be within the class interval of 25 to 29. This is the median interval, and its the lower value is 24.5. Thus, the cumulative frequency at that place is 8, as we can see from the earlier table. Now, the size of the class interval is 5. With given this data, you just push it in the formula and you get the median of this class intervals as 27. The next one is the central tendency, which is called mode, and we use often in English modal value. Modal value is the value which occurs often in a particular series. Now, we have a series 12, 13, 17, 12, 22, 12, 12, 23, 12, 18, 19, 12, and you don't need any calculator in order to calculate mode in this, because 12 has been appearing continuously and more number of times, and therefore 12 is the modal value of this series. Listen here, that there is a kind of distribution which is called a normal distribution. Largely, this distribution of any data is spread like a bell shape, inward, like a bell shape, and the normal values or mean or median or mode, they come in the central, but then they have a relationship between. Mode comes at the top of the distribution, median comes at the second level, and mean comes at the third level when the left skewed distribution and the right skewed distribution, both of them have the same thing and similar kind of relationship. This is something which is to be learned, but then there is a word of caution that every central tendency does not describe the data in full. 2, that any work on central tendency must keep in view the extreme values, say the lowest value or the highest value. 3, that central tendency does not necessarily tell us more than what is the central value or what is the series leading at. With these words, thank you, we'll look into it.